This is part 284C3M1B7C8E13C9C6D3P38D19D1. Sorry. Line 22f1fa19C3M1B7C8E13C9C6D3P38D19D1. Hertzian Dipole loop pattern formula 5G Wow Seti. There's the alien radio signal, and there's the stuff there. Okay, so this is a keyword research into Hertzian Dipole loop patterns from a dipole antenna for the UFO spaceship long distance deep space communication signal device found in the WOW data. Repetitive, aren't I? Okay, so February 24, 2013. Here we go. All the references back to the videos. I do shorten it as we go along because it gets longer and longer and longer. Today's March 11th. I'm half asleep. Sorry. Martensite-austenite crystals. Previous video, line 22f1fa19C3M1b7C8E13C9C6D3P38D13 Nano carbon steel metals UFO 5G Wow Seti. I apologize if you're watching all the videos. It does get repetitive listening to the same thing over and over again, but I have to do it this way because I have new people looking at these videos all the time and they're completely lost when they come in and they don't know what I'm talking about. So now I'm trying to connect the different videos together so they know what to refer to when we're working on a certain formula. Okay, so keyword from the data: Natrolite to Zincblende structure. Oh, so I did shorten it. So keywords: Zincblende structure and cubic crystal system, tetrahedral coordination, and a dipole, and then we have dipole antenna, and of course we came from there to this other one. Line 22f1fa19C3M1b7C8E13C9C6D3P38D19 tetrahedral coordination magnets UFO 5G Wow Seti. Then we had dipole antenna, elementary doublet, and Hertzian Dipole, which is the one we're looking at now. Line 22f1fa19C3M1b7C8E 13C9C6D3P38D19C dipole antenna radiation signals 5G Wow Seti. The keyword Hertzian Dipole. This will be part 2, is going to continue in the next video. Okay, so I took the data from one site and divided it into 2 just to make it smaller. Quotes and diagrams from a blog. Okay, so these are the power patterns shaded. The Hertzian Dipole is on the left with an E signal, and the small loop with an H signal on the right. So the behavior of a small loop has some similarities to a Hertzian Dipole. For example, it has the same antenna power pattern but are oriented such that the nulls, which is for a dipole, are along the direction of the dipole wire, are aligned perpendicular to the plane of the loop. The main difference we'd observed in the far field patterns of that electric and magnetic fields have been swapped over. Hence, defining the direction angle theta to be with respect to the perpendicular to the loop plane, we can say that for a loop, the electric field radiated into the far field will be, and here's an equation for you to look at. So comparing this with the expression we obtained earlier for a dipole, we can see that it shows the same angular dependence, but it's scaled slightly differently. It also depends upon ratio between the loop's cross-sectional area A and the wavelength squared rather than the ratio of the dipole's lengths to the wavelength. The other distinction is that the electric field component is parallel to the plane of the loop rather than parallel to the dipole wire. And I found that at www.standrews, there's a dash, st-andrews.ac.uk. Okay. On March 9th, formula from the data. Small loop, Hertzian Dipole, antenna, power pattern, dipole, direction, dipole wire, nano wires, micro wires, fiber optic wires, nodes, tetrahedron triangle. Dipole aligned perpendicular plane of the loop, difference observed far field patterns. Electric magnetic field swapped over, defining direction, angle, theta, perpendicular loop plane, loop electric field radiated far field algorithm. Dipole shows same angular dependence, scaled differently, ratio between loop, cross-sectional area A, wavelength squared, ratio dipole length to wavelength. Electric field component parallel to plane loop, not parallel, dipole wire, nanowires, microwires, fiber optic wires. March 9, the keyword Hertzian Dipole data from this blog will continue in the next video. It's from the same blog, and I had to divide it into two. Okay, thank you for watching.